Look up at the night sky. What do you see? A vast, dark canvas, dotted with countless tiny, twinkling points of light. It looks peaceful, doesn't it? Serene. Almost eternal. For most of human history, this is exactly what we believe the cosmos to be, a slow-moving, majestic, and unchanging clockwork of stars and planets. It's a comforting illusion, one that speaks to order and permanence. But this view from our little planetary oasis is a complete deception. The universe is not a quiet, still painting. It is a dynamic, violent, and incredibly energetic arena. Those twinkling stars are not gentle candles, they are colossal infernos, raging with nuclear fires. The dark spaces between them are not empty, they are filled with invisible forces and objects of almost unimaginable power. We are living in a cosmic shooting gallery, and we have only recently begun to understand just how many bullets are flying past us. Our journey today is to uncover the identity of what could be considered the single most dangerous object in the universe. This isn't about something that might give you a nasty cut or a bruise. We are talking about a phenomenon with the power to sterilize entire planetary systems, to snuff out suns like candle flames, and to rewrite the very fabric of space and time around it. It is a fundamental engine of destruction, and its danger lies not in malice, for it has no mind, but in its sheer, unstoppable physical power. And the most startling part? This object isn't a distant myth. It is a real, known entity that astronomers observe regularly. In fact, one of its kind could be forming right now, in our own galactic neighborhood. The danger is real, it is cosmic, and understanding it is key to understanding our true place in this violent, beautiful, and unforgiving universe. So, let us begin our search for this ultimate destroyer. Where should we look first? Let us turn our gaze to the most violent explosions since the Big Bang itself. If we are looking for raw, instantaneous power, we need look no further than gamma-ray bursts, or GRBs. Imagine taking all the energy our sun will release over its entire 10 billion-year lifetime. Now, imagine compressing that entire output into a beam of light that lasts for just a few seconds. That is the power of a gamma-ray burst. It is, for a brief moment, the brightest event in the entire universe since the Big Bang. So, what creates such a cataclysm? A GRB is the death scream of a very specific type of massive star. When a star many times more massive than our sun runs out of fuel, its core can no longer fight the immense force of its own gravity. It does not just gently collapse, it implodes catastrophically. In a fraction of a second, the core turns into an incredibly dense object, but we will come back to that later. This collapse triggers a supernova explosion, but that is just the opening act. The real show happens when the newborn object at the center, spinning furiously, focuses the explosive energy into two incredibly narrow, powerful jets. These jets, moving at almost the speed of light, are like the cosmic version of a laser cannon. They are packed with the highest energy form of light, gamma radiation. If a GRB were to occur in a nearby galaxy, and one of those jets were pointed directly at Earth, the consequences would be apocalyptic. The gamma rays would not just pass through us, they would rip our planet apart from a distance of thousands of light years. They would smash into our atmosphere, chemically transforming it, burning away the ozone layer that protects us from the sun's ultraviolet rays. The sky would literally glow with a deadly, invisible light. It would trigger a global firestorm and bathe the surface in lethal radiation, causing a mass extinction event that would make the asteroid that killed the dinosaurs look like a minor inconvenience. GRBs are a strong contender for our title. But they are not the object itself. They are merely the symptom, the flash of light from the true engine of destruction. So, if the gamma-ray burst is just the flashbang, what is the grenade? The true engine at the heart of this cosmic catastrophe is a newborn black hole. We have found our most dangerous object. But to understand why it is so dangerous, we need to move beyond the common idea of a black hole as a simple cosmic vacuum cleaner. A black hole is not just a dense ball of matter. It is a region of space where gravity has become so overwhelmingly powerful that nothing, not even light, can escape its grip. The boundary around it, the point of no return, is called the event horizon. Think of it like a cosmic waterfall. If you are far away from the waterfall, you can swim safely. But once you cross the edge, the current becomes irresistible, and you are pulled inevitably downward. The event horizon is that edge in space. Now, let us go back to our dying massive star. As its core collapses, it is squeezed with so much force that the protons and electrons that make it up are crushed together, forming neutrons. If the core is heavy enough, even this neutron star cannot support the weight. The collapse continues, and the gravity becomes so intense that it punches a hole in the very fabric of spacetime itself. A black hole is born. This newborn black hole is not yet stable. It is surrounded by a vast, swirling disk of leftover stellar material, a chaotic whirlpool of superheated gas and dust known as an accretion disk. As this material spirals inward at near-light speeds, it is heated to temperatures of millions of degrees, glowing brilliantly and emitting vast amounts of energy. It is the friction and magnetic fields in this accretion disk that power those two deadly jets of the GRB. The black hole, in its violent birth, uses the last remains of its parent star as the fuel for the most powerful explosion in the universe. But the danger of a black hole does not stop after its birth. The raw gravitational power of a black hole creates effects so strange they seem like science fiction. The most famous of these is spaghettification. It sounds silly, but the reality is terrifying. Imagine you are an astronaut falling feet-first toward a black hole. The force of gravity on your feet is vastly stronger than the force on your head, because your feet are closer to the black hole's center. This difference in gravity, called a tidal force, doesn't just pull you, it stretches you. You would be elongated, pulled out like a piece of hot cheese into a long, thin string of atoms, a human strand of spaghetti. But this is not just about getting too close. Black holes can wreak havoc without you even crossing the event horizon. Consider a star that wanders too close to a supermassive black hole at the center of a galaxy. The black hole's immense tidal forces can stretch and compress the star, pulling it apart into a stream of glowing gas. This event, called a tidal disruption event, is a spectacular and violent demonstration of a black hole's power to destroy objects from a significant distance. This gravitational dominance means that black holes act as the ultimate cosmic architects. They can tear apart entire star systems that form too close. They can fling planets out into the dark void of interstellar space, becoming rogue worlds. They can capture stars into tight, deadly orbits, forcing them to live on borrowed time. And this brings us to a crucial point about their danger, their stealth. A lone, dormant black hole, with no nearby material to accrete, is almost completely invisible. It does not emit any light. It could be lurking in the dark between the stars, just a few light-years away, and we would have no idea it was there until its gravity started to perturb the orbits of distant comets or stars. Its invisibility makes it a silent, patient predator in the cosmic ocean. This all sounds like the plot of a distant, galactic-scale disaster movie. But is this danger truly relevant to us, here on Earth? The answer, surprisingly, is yes, and on multiple timescales. First, let us address the immediate threat. Are we in danger of being hit by a gamma-ray burst from a nearby stellar collapse? Fortunately, the chances are extremely low. The type of massive star that produces a long GRB is rare, and its deadly jets are very narrow. For Earth to be affected, a star would have to be both close enough and aligned perfectly with its jet pointed directly at us. There are no candidate stars in our immediate vicinity that are poised to explode in such a fashion. However, the universe is unpredictable. A GRB from a more distant star within our own galaxy could still have a significant impact on our atmosphere and climate. More pressingly, black holes themselves might be closer than we think. Astronomers estimate that there could be hundreds of millions of stellar mass black holes, the remnants of dead massive stars, drifting throughout our Milky Way galaxy. What if one of these dark wanderers was moving through our solar system? Even at a distance far beyond Pluto, its gravity would be a disruptive force. It would perturb the Oort cloud, a vast shell of icy bodies at the solar system's edge, sending a shower of comets hurtling inward. Some of these comets could cross Earth's orbit, increasing the risk of impacts. If a black hole passed closer, it could destabilize the orbits of the planets themselves, throwing our cosmic home out of its stable, life-giving path around the Sun. The good news is that space is overwhelmingly empty, and the probability of such a close encounter is vanishingly small in any human lifetime. But on cosmic timescales, it is a real possibility. So, we have crowned our champion. The black hole is, without a doubt, the most dangerous single object in the universe. It is a region of pure, uncompromising gravity, capable of destroying stars, powering universe-scale explosions, and lurking invisibly in the void. But to end the story here would be to tell only half of it. For in the grand, paradoxical narrative of the cosmos, the greatest destroyers are also the greatest creators. This is the final, and perhaps most beautiful, twist in our tale. The same supernova explosions that create black holes are also essential for life itself. When a massive star explodes, it forges heavy elements in its fiery heart, elements like carbon, oxygen, nitrogen, and iron. It then scatters these elements across the galaxy, seeding cosmic clouds with the building blocks of planets, oceans, and life. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was forged in the heart of a long-dead star and scattered by its violent death, a death that may have created a black hole. Furthermore, the supermassive black holes at the centers of galaxies, like Sagittarius A** at the heart of our Milky Way, are believed to play a crucial role in galaxy formation and evolution. Their immense gravity helps to hold galaxies together, and the energy from their accretion may regulate the birth of new stars. So, the black hole, this ultimate agent of destruction, is also a fundamental architect of structure in life. It is a reminder that the universe does not operate on a morality of good and evil, but on a physics of balance. The violence that can erase worlds is the very same force that made our world, and us, possible in the first place. Understanding this danger is not about living in fear, but about appreciating the incredible, dynamic, and interconnected cosmos we are so fortunate to be a part of.